So today we are going to integrate this expression square root of 1 minus t square with respect to t. And if we look at this expression, we see that it basically looks like the derivative of sine theta. The derivative of sine theta is 1 over square root 1 minus x square. And here we don't have 1 over, it is just square root 1 minus t square. And there is no x written over here. In place of x, we have t here. But it kind of resembles square root, the derivative of sine theta, because it has 1 minus x square kind of expression. So we will integrate this by using substitution, and we will substitute sine theta in place of t. So we also need to replace this dt. So because we want this integral to be in terms of theta. So we will take the derivative of this t with respect to theta. So it will become dt over d theta, and the derivative of sine theta is just cos theta. So this will become dt is equal to cos theta d theta. Now we will replace the values of dt and t in this integral. So it will become square root of 1 minus t is sine theta, so t square will be sine square theta, and dt is just cos theta d theta. So this whole integral is now in terms of theta. So now we will evaluate it. So 1 minus sine square theta is just cos square theta. I have written the identity sine square theta plus cos square theta equal to 1. So from this identity, cos square theta is just 1 minus sine square theta. So we can replace cos square theta, 1 minus sine square theta, with cos square theta, and square and square root cancel out. So we are left with cos theta into cos theta d theta, and cos theta into cos theta is just simply cos square theta, and we are integrating this with respect to theta. So cos square theta is basically not the derivative of any function. So we need to change this cos square into simply cos. We don't want this square because we can't integrate this square. So we will use this identity cos theta is equal to square root of 1 plus cos 2 theta over 2. So this identity basically converts half angle into double angle. So we can see that we have cos theta. So here theta is just 1, cos 1 theta, and on the right hand side you can see that it has become cos 2 theta. So we will use this identity to integrate this cos square theta. So from this identity we can see that if, cos square theta is just 1 plus cos 2 theta over 2, because on the right hand side square and square root cancel out each other. So we can write cos square theta equal to 1 plus cos 2 theta over 2, and we can split this 1 plus cos 2 theta over 2 in the form of 1 over 2 plus cos 2 theta over 2. So we can use the linearity property of integration, and can separate these integral on these two terms separately. So we are left with integration of 1 over 2 with respect to theta plus integration of cos 2 theta over 2 with respect to theta. So I'm taking this 1 over 2 outside because we can take the coefficient outside the integral. It makes no difference. So we are left with integration of 1 with respect to theta, and in the second term we are left with integration of cos 2 theta with respect to theta. So now we can see that we can easily integrate these two things, 1 and cos 2 theta. So we need to just basically think that what is the which function has a derivative equal to 1. So theta, so the derivative of theta is basically 1. So the antiderivative or integral of 1 will be just theta. And now we have to think that uh, which function has the derivative cos 2 theta. So we know that if it was just cos theta, we would have said that the antiderivative of cos theta is just sine theta, because the derivative of sine theta is just cos theta. But we can't just say here that the antiderivative of cos 2 theta is just sine 2 theta, because sine 2 theta has a derivative of um, sine 2 theta into 2, because we have to take the derivative of the argument as well, and the derivative of argument is basically 2, because the derivative of 2 theta is just 2. So here the 2 part is missing. 2 is not written alongside cos 2 theta. So in order to compensate for that 2, we need to basically divide um, by 2, uh, and so that uh, uh, 2 which comes in the derivative of sine theta or sine 2 theta basically cancels out. And so the function which has the derivative of cos 2 theta is sine 2 theta divided by 2. So we are left with 1 over 2 theta plus 1 over 2 times sine 2 theta over 2. And we you can also verify that whether we have found the correct antiderivative or not, because we can easily take the derivative of sine 2 theta over 2, and we can see that whether it comes as cos 2 theta over 2 theta or not. So sine 2 theta over 2 is just simply 1 over 2 will be the coefficient, so it can be taken outside, and sine 2 theta has the derivative cos 2 theta into 2, so 2 and 2 cancel out, so you are left with cos 2 theta. So this is the correct antiderivative. And this becomes 1 over 2 theta plus sine 2 theta over 4, because 2 and 2 are multiplied. So this is basically the antiderivative of square root of 1 minus t square. But this is not in terms of theta, and this can't be the final answer. So we have to replace these thetas with t, or write these thetas in terms of t. So theta was t was just simply sine theta. So from that equation, theta is equal to sine inverse of t. So I have written this 1 over 2 and written sine inverse of t in place of theta. So now we have to uh, uh, need to find the value of sine 2 theta in terms of t. And here we will use an identity, and the identity is basically sine 2 theta, it is equal to uh, 2 sine theta cos theta. Here I have written this identities, 2 sine theta cos theta, and this identity basically comes from a formula which we use when we find the formula of sine 2 theta, and that is basically um, sine of theta plus theta, and we use sine of alpha plus beta formula, and we can find this um, formula from there. So in order to find sine 2 theta, we basically need the values of sine theta as well as cos theta. We know what sine theta is, it is simply t. So we need to find the value of cos theta in order to find the value of this sine 2 theta. So for that, we will draw a right angle triangle. So I have drawn right angle triangle here, and sine theta was just t, and sine theta is equal to perpendicular over hypotenuse. So basically we are saying that perpendicular is t and hypotenuse is just 1. So we have perpendicular and hypotenuse, and we need base. So from Pythagoras, uh, we have this hypotenuse square is equal to base square plus perpendicular square. So if we find base from that particular equation, we have hypotenuse square, which is 1, and base, I'm calling it b, we don't have base yet, and perpendicular is just t. So 1 square is equal to base square plus perpendicular square, which is t square. So from this equation, base square is equal to 1 square minus t square, and 1 square is just 1, and base square is equal to 1 minus t square. So we need to find base from this equation, and for that we have to take the square root. So we take the square root of this equation, and we are left with square root of 1 minus t square. And now we have the base, so we can find the value of cos theta. Cos theta is just base or hypotenuse. So base is just square root of 1 minus t square, and hypotenuse is just 1. So cos theta is square root of 1 minus t square. And sine 2 theta, we have the value of sine theta, which is t, and we have the value of cos theta now, which is square root of 1 minus t square. So we can simply put these values in this formula, and can find the value of sine 2 theta, which is simply 2t square root of 1 minus t square. So this is basically the final value of sine 2 theta, and we need to replace it here to find our final answer. So it will become 2t square root of 1 minus t square over 4. So 2 and 4 cancel out. So we are left with 1 over 2. So it becomes 1 over 2 sine inverse of t plus t times square root of 1 minus t square over 2. And we can take the LCM. So it will become sine inverse of t plus t times square root of 1 minus t square plus the constant of integration. So this will be our final answer.